Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on March 3, 2026, just 2 days ago. It introduces a unified framework for character animation that boosts inference speed by over 10 times, while decisively outperforming leading commercial solutions in human preference evaluations. The paper is titled Kling-MotionControl Technical Report. And as we'll see later, the model's ability to handle complex hand interactions and facial expressions without losing identity is really impressive. Figure 1 provides a high-level overview of the system's capabilities across 3 distinct tasks. The top section illustrates fine-grained control, where the model transfers detailed facial expressions to a realistic portrait and complex hand gestures to an anime character. In the middle rows, we see robustness to challenging dynamics, like a cartoon cat performing acrobatics. Finally, the bottom strip highlights cross-identity generalization, showing a dinosaur character faithfully mimicking human dance moves without losing its visual identity. Alright, moving under the hood. Figure 2 outlines the training and inference pipeline. The top half displays the training phase, where a teacher model first learns to handle detailed motion and identity. This knowledge is then transferred to a student model through distillation, which is the key to that 10 times speedup. The bottom half shows how inference works. The system combines a reference image and a subject library, which provides extra context for the character, with a driving video that dictates movement. These inputs feed into the student model to generate the final output. So, having seen the architecture in Figure 2, Table 1 now quantifies how users actually feel about the results compared to top competitors. This table lists preference ratios based on a good, same, bad, or GSB protocol, where human evaluators compared the outputs against Dramina, Runway Act 2, and One Animate. The results are quite striking. Against Runway Act 2, the overall preference ratio hits 16.25, indicating a massive lead. Even against strong baselines like Dreama and One Animate, the model scores roughly 3 to 4 times higher, showing consistent strength in identity preservation and expression accuracy. While Table 1 listed summary ratios, Figure 3 breaks down the preference percentages across 6 dimensions. The graphic separates results into 3 columns, comparing against Dreamina on the left, Runway Act 2 in the middle, and One Animate on the right. The dark green bars indicate where the proposed model was preferred. In the middle column, against Runway Act 2, the overall preference reaches nearly 94%. Even against the other competitors, the model secures over 70% of the overall votes, though lighter green segments show more ties in metrics like expression accuracy. So, while the bar charts showed user preference, Figure 4 provides the visual evidence behind those scores. This grid compares the method against the 3 baselines across 4 challenging scenarios. In the top left block, look at the man touching his face. The proposed model, in the second row, cleanly separates the fingers from the facial features, whereas the competitors often blur them or distort the identity. Moving to the bottom rows, which feature rapid martial arts and dancing, the model maintains limb consistency and background stability even during fast, sweeping movements. Well, having established the competitive edge in the previous comparisons, Figure 5 now showcases the sheer versatility of the system across 6 distinct scenarios. The top 2 strips focus on fine-grained details, accurately transferring intense facial expressions and complex hand gestures to stylized characters. Moving down, the middle rows demonstrate robust body dynamics, handling everything from the rapid spins of a figure skater to a 2D cartoon walk cycle. Finally, the bottom row highlights text controllability. Here, the model follows a prompt to generate a corgi running around the girl, seamlessly integrating new semantic elements that were not present in the original reference. Wrapping up, 2 takeaways stand out. Kling-MotionControl effectively reconciles the trade-off between large-scale structural stability and fine-grained detail, handling tricky areas like fingers and faces with ease. Plus, the multi-stage distillation offers a 10 times speed boost, making high-fidelity animation far more practical for creators. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.